So let's start with quadratic inequalities. So let's look at this one here. X squared minus 3x minus 4 is greater than 0. Whenever we see an inequality like this, first thing I like to do is to essentially change this inequality greater than to an equals to. X squared minus 3x minus 4 is equal to 0. And then we would factorize here, as we would. So in order to factorize the quadratics like this, we need to find a number that times to make this -4, so times to make -4, and adds to make -3. In order to do this, we look at our factors of 4, which is 1 and 4 and 2 and 2. And because it has to times to make -4, the two numbers have to multiply to get -4, that means that one of our numbers has to be a negative and the other one has to be positive. And as we can see, this pair would have to be -4 and 1. -4 times by 1 makes -4, and -4 plus 1 makes -3. So that is what's going to be inside our brackets now. X minus 4 and x plus 1 is equal to 0. So from here, we need to work out what x values could be. So in order for these two to times to make 0, that means that one of these numbers in the brackets needs to be 0. So x minus 4 needs to be 0, or x plus 1 needs to be 0. So if we look at x minus 4, if x minus 4 has to equal to 0, that means that x has to equal to 4. Because if we do x minus 4 is equal to 0, and we rearrange our equation to get what x is equal to, we have to add 4 to both sides to get x is equal to 4. And same thing here, x will have to be equal to -1. Okay. So x is equal to 4 and x is equal to -1 are our x-intercepts, solutions, or roots, essentially. Next we do is draw a sketch of our graph. So just a quick sketch of it, doesn't have to be perfect. So this is our x-intercept, so -1 and 4. And our y-intercept is -4 because if we look at x squared minus 3x minus 4, this number here next to the number 3, next to -3x, tells us what our y-intercept is. Okay. So then we go back to our inequalities. So if x squared minus 3x minus 4 has to be greater than 0, so our 0 is essentially here. That means we need to look at parts of the curve that is going to be above 0. So essentially above the x-axis here. So that means that we are looking at this one here and this one here, as they are above the x-axis essentially, so they are above 0. Okay, so how would we write that in inequalities? So we're going to say that x has to be less than -1, so x is less than -1, or x has to be greater than 4. And that is it with inequalities. Next one here. Okay, so now we've got something a little bit harder. We've got 2x squared plus 3x minus 3 is less than 0. So as we did before, change the inequalities to an equals, so 2x squared plus 3x minus 3 is equal to 0, and then we would factorize as we normally would when we have a quadratic equation. So now that we've got a 2 next to the x squared, what we do is we do 2, so this number next to the x squared, 2 times by this negative 3, which would make negative 6. And same thing as we did before, we have to find two numbers that multiply to make negative 6 and add to make 3 here. In order to do this, we think of our factors of 6. So we've got 1 and 6, and 2 and 3. Okay, let's see. Any numbers from here that add to make negative 6, that times to make negative 6? Yeah, but do they add to make 3? No, they don't. So that means that we are not going to be doing this method here. So that leads to two methods we can do, which is completing the square or quadratic inequality, or sorry, quadratic formula. Okay. Again, doesn't really matter which one we do, but let's do the quadratic formula. So the quadratic formula is minus b plus or minus square root of b squared minus 4ac over 2a. Okay. And the number next to our x squared is our a, the number next to our x is our b, and the number left is our c. Okay, so we have minus 3 plus or minus 3 squared, well, square root of 3 squared, minus 4 times by 2 times by negative 3, square root of that one, over 2 times by 2. Okay. So if we look, okay, we get minus 3 up here. And then 3 squared is 9. 2 times 3 is negative 6. Negative 6 times by negative 4 is positive 24. So we're doing 9 plus 24, which is 33. So plus or minus square root of 33 over 2 times 2, which is 4. And that is what x is going to be. Same thing we do, draw our graph or sketch our graph. So let's put this into decimals. So we get x is equal to either 0.686 or x is equal to negative 2.186. Okay. So looking at our graph, it should look something like this. Okay. So this would be our negative 2.186, and this here would be our 0.686, and our y-intercept is negative 3 as stated there. Okay, so now, and also just for us to make sure, add the 0 there, just so that we know that that is 0. Okay, so now we've got 2x squared plus 3x minus 3 has to be less than 0. So if we look at our curve, if it has to be less than 0, that means it has to be, we have to look at bits of the curve that are below the x-axis. So that means we are going to be looking at here. Okay, so we can see that x has to be in between the x-intercepts. So we write it as x has to be, well, less than our 0.686, but it has to be greater than, or let's say minus 2.186 is less than x. Or you can say, essentially say that x has to be greater than minus 2.186. And that is it. Okay, so a rectangular garden has a length of, well, has a length that is 3 meters longer than its width. Okay, that is important, so we should highlight that. And the area of the garden is 40, so area, let's highlight that, is 40, well, is more than, not just 40 square meters, is more than 40 square meters. Find the possible range of values. Okay, so that already tells us that we're going to be doing quadratic, we're going to be using some sorts of inequalities anyway, of the width of the garden. Okay, very good thing for us to underline or highlight key information in our question, just so that we don't miss any vital things that we may need to do to answer these sort of questions. So first thing I like to do is to draw a rectangle. So just have an idea of, okay, what we are working with. So this is a rectangular garden. Its length is 3 meters longer than its width. So let's say the width is x. If the length is 3 meters longer than its width, that means that we're going to do the width, which is x, add 3 meters, essentially. So the width is x and the length is x plus 3. And we are told that the area, so A, is more than 40 meters squared. So now what we're going to do is think of that formula that tells us the area of a rectangle, which is A is equal to length times width. So essentially we just substitute in our values here. So our length is x add 3 times by x, which is our width. And because it has to be more than 40 meters squared, we add that inequality. It's more than 40. Next we do is we expand the brackets. So x times by x, which is x squared, and 3 times by x, which is plus 3x, is greater than 40. Next thing we do is we are essentially trying to form a quadratic inequality, meaning that this side on the right hand side, this 40 needs to turn into a 0. So in order to eliminate this 40, we have to subtract it on both sides. So if we subtract 40 on both sides, we get x squared plus 3x minus 40 is greater than 0. Then, as we normally do, we would factorize the x squared plus 3x minus 40. Okay, we have to think of two numbers that times to make negative 40 and add to make 3. Okay, factors of 40, you've got 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Okay, so in order for the two numbers to multiply to make negative 40, that means one of them will have to be negative. Okay, let's look. Okay, I can see 8 and negative 5. 8 and negative 5 do add to make 3. Okay, so those are our numbers. So in one bracket, we're going to put x plus 8, then in our other brackets, we're going to put x minus 5, and that has to be greater than 0. So x here would have to be negative 8, and x here would have to be 5. And then from here, what we would do is draw a rough sketch of our quadratic curve. So we're going to get something like this. This is -8 and this is 5, and our y-intercept is going to be -40. And then put our 0 so we know where it is, our y and our x. Okay, so for x squared plus 3x minus 40 to be greater than 0, that means we are looking at lines of the curve, of the quadratic curve, which is above the x-axis, which is higher than 0 essentially. And that is going to be this one here and this one here. So that means we are saying that x has to be less than -8 to satisfy this one here to the left, or x has to be greater than 5 to satisfy the one on the right. But that is not it, because we always have to put our answer in the context of this question here. So it tells us to find a possible range of values for the width of the garden for x. So if we look at x has to be less than -8, that means we're saying x could be -9, -10, -11, and so on and so forth. But because of the context of the question, and we are using measurements, so meters, measurements and lengths, we can't have a negative measurement. We can't have -4 meters, or negative, in this context, -9 meters. So that means that this x is less than -8 won't work in the context of this question. So we scrap that. So that means that in this context of the question, x has to be greater than 5.